Welcome to Study Loop.
Okay, so in this question, we know that an electron in hydrogen has an energy of 0.544 eV. And we also, and we want to know, I guess, what are the possible values of orbital angular momentum? Well, we need to find the n, the principal quantum number for this electron. And so we can do that based on information in the other chapter, the previous chapter, which says that the energy levels in the hydrogen spectrum are negative 13.6 over n squared. So if we plug this in for E and solve for n, we would get n equals 5. So that means that little l can equal 0, 1, 2, 3, 4, all the way up to n minus 1. And so we want to get the possible values of orbital angular momentum in terms of h bar. So we just want to use this L equals the square root of L times L plus 1. And so therefore times h bar. And so the possible values are L. If you plug in 0, you'll get 0. If you plug in 1, you'll get the square root of 2. And if you plug in 2, you'll get square root of 6. If you plug in 3, you'll get the square root of 12. And if you plug in 4, you'll get the square root of 20. And then that's all in units of h bar. And then the next question is saying what wavelength to the next higher shell. So that would be, so we want to find the current shell. So it's the energy difference between the final and current shell. So the final shell would be n plus 1. So that's 13.6 divided by 36 minus the negative 13.6 over the current n, which is 5. So it's 5 squared equals 25. And then we would set that energy difference equal to hc over lambda and solve for lambda by cross multiply, for example. So I'm going to pause the video while I do that calculation. Okay, I got 7,470 nanometers. And then that's much too large to be seen by humans. Humans, I think, can see maybe up to maybe a bit less than 1,000 nanometers. 556 is in the middle, 300 something maybe is the lower end. So I would say that this is definitely, you can't see it. Yeah. So I guess I'll just write down that answer. No. Invisible.